This is a video to talk about multiplication as repeated addition. So we're going to look at positives multiplied by positives and positives multiplied by negatives. In this first problem, we're starting with a repeated addition, meaning we're adding the same number to itself multiple times. In this case, we're adding the number positive 4 to itself multiple times. We can rewrite this as a multiplication problem, but there are a few things we have to pay attention to do that. First, we want to notice how many groups of 4 do we have. So I'm looking at this. I have 1, 2, 3, 4, 5. Well, I have 6 groups of 4. So to write this as a multiplication problem, I'm going to note that I have 6 groups, and in each of those groups, I have positive 4. So these are two equivalent expressions, starting with 4 plus 4 plus 4 plus 4 plus 4 plus 4 should be equivalent to multiplying 6 by 4. And I can prove that using my number line and algebra tiles again. So if I look at this on my number line, I'm being told I'm moving 4 each time, and I'm going to start at 0 when I'm using the number line model here. So I start at 0, and I first move one jump of 4, so that's one of my groups. I'm going to move another jump of 4. That's 2 groups, 3 groups, 4, 5, and 6 groups of 4 here. So I can clearly see, and I'm making the larger jumps to make it easier on myself rather than having to keep track of how many groups of 4 I have. So this is my first, second, third, fourth, 5, well, that's 6 groups right there. In each group I have 4, and I end at 24. Well, both of these should be equivalent to 24. And knowing my addition facts and my multiplication facts, I know that to be true. I could also show this with my algebra tiles by showing that I have 6 groups again with positive 4 in it. So I'm going to actually just draw what that would look like. In each of my groups, I'm going to have 4 of the positive or blue algebra tiles. So right here, that would be considered one of my groups. I'm going to circle this to prove, hey, this is one group, and I need to do that with the rest of my groups as well. So 1, 2, 3, 4, and I'm going to stop drawing the squares just because it saves me sometimes. I have 1, 2, 3, 4, 1, 2, 3, 4. I have 4 groups total. 1, 2, 3, 4, 1, 2, 3, 4. And if I look at this, because I have all the tiles, I could just count how many tiles I have in each of these groups, and that would give me the total value of both of these problems. So if I look, I have 4, 8, 12, 16, 20, 24 tiles total. That's how we show it with the number line and with the algebra tiles. Now let's look at a problem where we are repeatedly adding negative numbers. In this case, we're repeatedly adding negative 7. I have 3 groups total, 1, 2, 3, of negative 7. So I could rewrite this as a multiplication problem as 3 times negative 7. Because I'm multiplying negative numbers, I'm going to be moving to the left on the number line, starting from 0. So I start from 0, which is on this side of this number line, and I want to move to the left. The number inside the parentheses is telling me how many is in each group. So right here I'm saying I'm moving left 7 for my jump, and I have 3 of those jumps to make. Second one, and I actually am 1 shy here, so I have to kind of add in. It would really end right about here. Well, that would be negative 21 for my total. So that's how I would show it on my number line. I have 1, 2, 3 groups of negative 7. With the algebra tiles, I would show that by drawing 3 groups with negative 7 tiles inside those groups. So I have 1, 2, 3, 4, 5, 6, 7. That's one group. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So altogether, I have one group with negative 7. I have a second group with negative 7. And I have a third group with negative 7. If I were to count all of these algebra tiles, because they are all negatives, I would notice that I have 21 of the negative tiles. I landed at negative 21 on the number line. So the product of this is going to be negative 21. And I showed it with both the algebra tiles and with the number line. What we found out and determined in class today is that if we had a positive number and we multiplied that by another positive number, our total value, the product at the end, would be positive. If we have a positive number and we multiply that by a negative number, our product will be negative. So we just have to multiply those together and then keep the sign depending on which type of problem we are solving. Thanks.